Hello, everyone. My name is Franklin Hu, and today I'm going to do a reaction video to what Draftscience just published today, which was an interesting simulation of his 2+2+2 physics, is what he calls it. But what it's really showing is why in the world would, say, a proton attract an electron, which is a very fundamental problem. And most people just eventually, just say, well, plus attracts negative because plus attracts negative. That really doesn't solve things. So, I would congratulate Draftscience on, actually coming up with, I would say, at least a plausible, reasonable way of explaining, why electrons should attract protons. And he actually built a simulation out of Blender. So if you haven't seen that, I'll see if I can link that below so you can see the original video. But the strange thing, he doesn't really explain exactly what's going on with the simulation here. So I'm going to try and show that with this one little chart here. And what he has is that he has a big red dot, big red dot, and a big blue dot. And what you can see is that what's happening in the blue dots is that tiny little blue dots are flying out of here. And what's flying out of the red dot are other tiny little red dots. So this is part of his 2+2+2 explanation, in that he says that there are, for example, two kinds of matter. So like you have the positive matter and then you have the negative matter. And then he says you have two force bits and they are similarly colored. So we have these little blue force bits and there's the arrows showing the directions. And so the matter bits are spitting out these force bits of the thing. And then there are just two interactions, so that if like the blue bit hits the red bit, it is simply absorbed. But if you have another red charge here, and this red bit hits the red matter, it causes a reflection, and that reflection is actually a collision, and that causes the red particle to be pushed in the opposite direction. So you can see that as long as it keeps on getting hit by the red bits, it's going to get further pushed away. And I think the simulation was such that if a blue bit hits the red thing, that not only does it get absorbed, but it also seems impelled towards the opposite direction. But that just seems to be the way the simulation works. Now, so the purpose for Draftscience is to get confirmation of this picture, whether this is right or wrong. And so that is what is the purpose of my reply here. And I would say that the main problem with this is that you've simply replaced one mystery, which is, why do positive charges attract negative charges, with an even equivalently harder problem, which is, what are the blue bits, what are the red bits, and what is it about the physicality of the red bit such that when it gets the red part of the red matter, such that when it gets hit by the red bit, it causes a reflection. And how does it know that it got hit by the red bit? How does it know it got hit by the blue bit? You've just pushed the question about how these things attract and repel to another level. And the other problem is, well, how would we prove this with a physical experiment? Because science is about having hypothesis. For example, this is a hypothesis. I think it's a legitimate hypothesis. And I think that there actually has a lot that is right about it. I mean, I think actually this is, in a way, actually it's totally right. But it still has to be testable, right? So unless you have any way of, identifying what these force bits are, I mean, is there an experiment that you can devise that can tell me that these force bits exist? Or can I make a stream of these things? Can I make a particle beam of just like red force bits and then compare them against a beam of the blue bits? So generally speaking, I don't think so. But like I said, I think that this is a great idea. I think it's actually correct, but it doesn't quite get all the way down to something which is not yet another mystery. In order to get this down to something which is not another mystery, we would have to get it down to just plain Newtonian mechanics. So the only thing that we have in Newtonian mechanics is that we know that when one bit hits another bit, there's going to be a collision, there'll be an exchange of momentum, and then both bits will fly away from each other. So this bit about, positive bits hitting each other, causing this bit to fly away, that's Newtonian mechanics. That's perfectly fine. The only problem is we can't explain why is it that when the blue bit does the same thing, that it doesn't do the same thing, because it should do the same thing, right? Any particles hitting any other particles should cause an elastic reflective collision. There wouldn't be two interactions, there'd only be one, and that would be the reflection reaction that pushes everything away. And in Newtonian physics, that's generally all we have. That there is, the problem is that there's no, say, attractive interaction in Newtonian mechanics. You've got two billiard balls. The only thing you can do is hit them against each other, and all that's ever going to do is cause them to fly apart. The only way you can get two billiard balls to roll towards each other is if you hit two billiard balls from the opposite sides, and then they will roll towards each other. But what generally happens is that there's really only a pushing force that's available. So like I said, my general conclusion is that I think what Draftscience has here is actually what is going on, and that there really are two force bits, there really are two kinds of matter, and there really are two types of interactions. But the question is, how do you make this actually work in, say, the known physics world? So I'm going to try and present how I think that works, okay? So this is my proposal. So like I said, I'm not really contradicting anything that draft physics has to say about this picture. I'm just going to try to explain what exactly these things really are, okay? Now, so I'm going to explain that in my hypothesis, that we do have these little bits that fly around everywhere, okay? That's true. And the question is, what are these little bits, okay? Now, it actually doesn't matter what these little bits are, other than they do act like, grains of sand, or flying everywhere, or like gas molecules. Doesn't necessarily matter what they are. If you ask me personally, I would say they're like neutrons. So that like the entirety of space is just filled with these neutral particles. But for the purposes of this explanation, the actual composition doesn't matter. So what are these bits? They're basically neutrons. Okay, now the question is, what are the force bits and what makes them different, right? Okay, so now you cannot distinguish any one neutron from any other neutron. But what you can do is that if you have this sea of neutrons, then you can create waves in those neutrons, right? Just like sound waves. And so what I'm thinking is that in the quantized world of space, we're going to have the only difference that you can have in a sound wave is actually the phase, right? So I'm going to say that what's really happening is that we have, the blue matter bits, and we have the red matter bits. Okay, so this is what I'm going to say is happening. You have the blue matter bits. They are outputting a wave in a certain phase. So let's say that we have phase that goes down and then up. Okay, and then we have the red matter, and that it is putting out a wave, but it's in the opposite phase. So when this thing is going down, this thing is going up, and it's just continuous. So this is what I would say is differentiating the blue from the red, that instead of being an actual particle or a bit, you can think of this as a wavefront. And this red thing is like when it's, say, pointing out of the screen, but the blue one thing is putting out waves, and so that's pointing, inward to the screen, right? So what happens is that we know that when waves of opposite phases come together, they cancel each other, right? So, but when the waves of similar phase come together, they add together, right? So this is what I am proposing to separate out what the red and the blue bits are. Is that they're, like I said, they're not bits, but I can think of them as waves. They're waves that are coming out. They're waves that are coming out from, say, the blue object. Let's just call that, say, negative. And then we have the same waves, which are coming out from the red object. Let's call that positive, okay? So what happens is that physically, is that when the red wave hits the blue object, it's going to be out of phase, and therefore it's going to cancel. So that when they come together, there's not going to be any net force. But when the wave from the red wave, similar wave, hits this thing here, then all of a sudden we have two waves pushing at the same time at each other, right? It's similar to, like, if I had my hands and things were in phase and I went like this, then they would never hit each other. There's no force would ever be exerted. But when you have in phase, then it hits each other, right? When you hit each other, then we have Newtonian force pushing the other thing away, right? You can always push it, but I'm gonna go like this. Nothing's ever gonna, they're out of phase. They're never going to push. Okay. So that would be, this is how you get the two interactions that he has. That you either have the in phase interaction, which is a push, which is going to be a Newtonian push, because ultimately there are going to be particles that are going to be smashing against each other, and they are going to push against each other. And that breaks down what actually causes the force down to only a Newtonian force, right? There's no necessarily an absorption force, an attractive force necessary to explain this interaction here. It's all just Newtonian. So we've taken it from another mystery, which is like, what are these blue bits? What are these force interactions? And broken it down to waves, which is just Newtonian. And this kind of interaction, actually, people 100 years ago have experimented with this kind of phase relationship. And they had like two pulsing balloons and found that, yes, indeed, if you had two pulsing balloons, if they're pulsing in phase, they will repel each other. If they're out of phase, they will in fact attract each other, because the particles in the surrounding, that they had it immersed in a water tank. All the little particles of water do actually act to push or pull these pulsing objects apart, right? So to conclude, I would say that yes, draft physics has shown a very interesting concept here, but one which is still not getting to the physical root of why, say, an electron should attract a positron. And so what I have done is that I've taken this idea and explained what each of these things could possibly be down to the Newtonian level, so that you can explain how these things are actually getting the two interactions which are required in Draftscience's 2 + 2 + 2 physics. So that's all I have for today. If you have any comments, please leave them below. Thank you.